Okay, here's a video of how to put together a flight coach system, all in one, start to finish, the whole thing, hopefully. This is an attempt anyway. So let's first of all just talk about what we actually need hardware wise, what to look for. Pretty much any flight controller is going to be able to run this. Three key requirements, two of which are almost certainly guaranteed, and the third you need to look for and check. Firstly, it's going to need an SD card. A lot of flight controllers these days come with onboard storage, but it won't be enough. So you need to have a flight controller that has an SD card slot. Secondly, it needs to run Ardupilot. So you need to check that the flight controller that you're picking actually has software available in Ardupilot, and I'll show you how to do that later. Thirdly, needs to have a GPS connection. Never seen a flight controller that didn't have one, but I'm sure there are some out there, so just make sure of those 3 points. That covered, you should be fine. Just a little bit about the chips that are used in flight controllers. Typically these days the most common is an F405 chip, hence the name of a lot of flight controllers, F405 something. But increasingly common is the F7 and H7 chips, far more powerful, tend to be about double the price, and probably not needed for this because we're going to be stripping back everything we don't need in the software later on anyway. So let's just have a quick look at what is available. As you can see, there's quite a lot of flight controllers around, so you need to check those 3 things. Having actually picked your flight controller, when you do pick one, you probably need to make sure what you're getting with it. So it depends on the GPS connection. Some have a physical plug and some have solder pads on the boards. So you may or you may not need some of the following. First of all, if you have a flight controller that plugs into a board, it's likely to have a plug that is something like this. You actually need a 6-pin electronic wire, because there will always be 6 connections on a GPS compass. You may also need these, they're called gummies. Basically these go into the board like that. They're anti-absorption, vibration absorption, and it just helps to mount it anyway, because you can't screw the board down because it's got components both sides. You may or may not, depending on how you want to power it, need some connectors. I use the flight batteries to power it. They use very little power, so you wouldn't even notice. So you might need some of those. If the board has holes for where the solder connections can go, you might want to use servo pin headers. If you do, you may also need servo connectors like these. You may also of course need some wiring for the power wire and various other bits that you might need them for. So, having dealt with that, this is the flight controller that we're going to be using here, and you can see on here what you're looking for is actually up here SDA, SCL, TX, RX, 4.5 volt and ground. When you see SDA and SCL, that tells you immediately that that is the GPS compass, because nothing else uses them. Also worth noting here is that typically in the description it will actually tell you that there is an Ardupilot software for this controller, and it will give you the exact name to look for in Ardupilot. You need to be a bit careful because a lot of these boards have very similar but aren't actually quite exactly the same name, so do check that. So this is the flight controller that we're going to be using today. Hasn't been soldered up yet. This has the compass GPS on pins, and the pins will go on the board like that, and then you just solder the other side. This is the compass GPS unit we're making. The chances of getting the right connection on the end of the compass that you get and the flight controller is almost zero, and you can see here that on this particular one I've soldered servo pins and sockets to connect to the headers that are going to be on the board. If you aren't sure of the wiring connections on the compass, you can actually generally take the lid off like this, and you will see the inside where the actual connections will be labelled. And when you wire it up, it will eventually look something like this. So let's go over to the internet, and while we're waiting for our flight controllers to arrive, we can get the software ready that we're going to need to put onto the flight controller. Now the first thing that we're going to need is going to be Mission Planner itself. If you just type into Google Ardupilot, search for it, and you'll find that one of the first entries that comes up is installing Mission Planner. You click on that, that will take you to a page where you can download it from here and just follow the instructions and install it like any other software. You will then also need the Cube programmer. The flight controller itself is highly likely to come with something called Betaflight on it, and we need to put Ardupilot on it, and to do that we need to use something like the Cube programmer, an STM32 programmer, and you can download that here. All of these links will be in the footer underneath the video, so download that, get that and install that. So we need to go to Ardupilot, and we're looking for this page here. We're obviously using a plane, so we select plane, and that brings up a list of all the software versions. We simply want the last stable one, which in this case is 4.62. So we go there, and we come up with a list of flight controllers. So look down the list for your flight controller. We're using the Maytec 405TE, this one here. So you click that, and that opens up the page, and the one you're looking for is this one here, Ardupilot with BL hex, with BL stands for with bootloader. You need to have a bootloader the first time you install Ardupilot on a flight controller. You won't then need it for any subsequent updates, but you definitely need it for the first time or it won't even start. So get that file, click on it, download it, and put that somewhere where you know where it is, because you're going to be using it fairly shortly. Next we can go to the custom firmware. Again, link is below, and we're going to add a build. First of all, we tell it that it's a plane, and you can't see the things that pop up on the screen, but you can see that I've selected plane. Stable 4.62 Ardupilot is the version we want, and when you click this button here, you'll get a list of flight controllers. Go down and pick the one for your flight controller, which, as you can see, I've just done. That will then give you a list, and here you can deselect the things that we don't need. So we're not going to be doing any VTOL, so we don't need that. We don't have a video transmitter, so we don't need that. We don't have any safety geofencing, so we can get rid of those. We don't have any sensors, so we can get rid of all of these. We don't have any telemetry, so we can get rid of all of this, because we don't even have a receiver connected to it. We don't have a rangefinder, so we don't need that. We do need in Ardupilot plane to select black box logging, but we can deselect the rest because we don't need any of these. We don't need to be notified of anything. We don't need Mavlink. We don't have a camera. We don't have a gimbal. We're not using the CAN bus. We don't need battery. We don't need files. We do need file system, I believe, so leave that. We need IMU, we need GPS drivers. On AHRS we do need to go in and select EKF2 as well as EKF3, and that looks pretty good so far. We don't have an on-screen display, we don't have an other, we don't have payload, so that is now beginning to look quite good. We don't need a rangefinder. We don't want other. Again, some of these keep coming back, as you can see. We don't want RC, and we do not want any sensors. That looks pretty good there. Once you've got that done, just check it. Excuse me, and go to the button at the bottom for generate builds. Click it, and that will go to generate the build. This is going to take a couple of minutes, so I'll come back. So once that's completed, that will download a zip file into your downloads folder like this, and you can unzip that file and that will create a folder, and in that folder will be 5 or 6 files. The one that we want is the one called Ardupilot APJ, so right click on that, copy it, and then put that in the same folder that you put the Ardupilot with bootloader file. We're going to be using those very shortly in a minute. So now we can go over to the Cube programmer and put Ardupilot on the board for the first time. So this is the Cube programmer. So connect the flight controller to the USB. While you're connecting it, you have to hold down the boot button. You should hear a satisfactory window sound. Up here you need to select USB, and when you click that you should come up with USB 1, and then you can click connect. So that's connected to the board now. You need to go to this second box down here, and you need to browse to the hex file for the Maytech, which unfortunately you can't see, but I have just done. And the first thing you do is the full chip erase here. Okay, that. You'll see a status bar at the bottom. It won't actually really go up, it will just suddenly say done. Okay, that. And then tick the box to verify program and run after programming. You've selected the correct file, start programming. Again, you'll see in the box below Ardupilot being put on and replacing Betaflight, which it almost certainly will have come with. And there you can see the software actually loading. And when that gets to 100%, it will tell you that the file download is complete. It will verify it correctly. That is that operation done. We can now go over and do the rest of the configuration in Ardupilot. But just before we do go to Ardupilot, just a few things worth mentioning. I mentioned in the Cube programmer you need to hold down the boot button. It's on the Maytech is this little button here beside my finger. It's likely to be the only button there is on the board anyway, but you need to find that when you use Cube. Also in the links below are links to a couple of files. There's, if you can't get the Cube programmer to connect to the board, you can use the Impulse RC driver fixer. You need to have the flight controller attached and powered on when you use that. If that fails, you can use Zadig, and there's a link to how to use Zadig in the description below. Another point worth mentioning, you really need to use a solder station to solder these. That's the tip that I'm using, particularly for soldering up the servo connections. The wires on the GPS are incredibly thin. Crimping won't really trap the wire properly or connect it properly, so you need to really fine solder it. If you use a normal soldering iron, you're likely to be in a world of pain, because all you're going to do is put so much heat into the wire that you'll melt the insulation and it will just make a real mess. This is pretty small and delicate stuff. The other thing worth mentioning, if you don't know, with the GPS unit you wire the SDA of the GPS to the SDA on the flight controller. Same with SCL, SCL to SCL, obviously ground to ground, power to power. But with the TX and RX, you reverse the wires, so the TX from the GPS unit goes to the RX on the flight controller and the other way round. So it's TX to RX, RX to TX. So having said that, we'll now go over to Ardupilot. Okay, so here we are in Ardupilot, and the first thing to do is to get our USB-C lead and connect up the flight controller to the USB-C socket. You should get an acknowledgement that that's connected. Now, we don't go to the connect up here yet. In the previous Q programmer, we used the file that we downloaded, which was the Ardupilot with BL hex file that contained the bootloader. This is where we use the other file that we downloaded, the APJ file. So to use that, we need to go to Setup, Install Firmware, and we need to go here to Install Custom Firmware. Click on that link, and that will take you to a folder where you can search the folder where you put the Arduplane APJ. You can't see that on my screen, but I can. So I've now clicked on that file, and you'll see here it's reading the hex file, and it will come up with this message that you can't see that says unplug the board, press OK and plug back in. So I'm going to unplug the board, press OK and plug the board back in, and you can see here that it's found it. Looking at it connecting, it's now erasing the original firmware on the board, and hopefully, there you go, it's now programming that APJ file onto the board. That's now done, so we can now go and connect to the actual board. So up here on the right are the various COM ports, and when you pull that down, one of them should say something like COM9 USB serial device. You need to click that. If there isn't anything else there, you can also use auto and then press connect. That will then look for the flight controller. It's found it, and we can go to config and we can look at the parameters. In the parameters, what you need to check is the following. Check that these parameters are the parameters that you have. So the first one being log underscore file underscore dsrm rot. Scroll down to log, go to log file, you'll find dsm rot. The value for that should be 1. If it isn't, change it to 1, then click write parameters. You need to check that log file rate max, this one, is also a 0. Moving on to black box SPD under arming. Black box SPD should be a 5. You can come down to EK2 and EK2 enable, and that should be a 1. AHRF or AHRS, sorry, EKF type should be 3. Again, under arming, require should be a 1. Log disarmed, under log, here should be 0, and log bit mask should be 65535. Any of those that aren't correct, change them and click Write Parameters. Right, let's go and do the rest of the configuration of the hardware. So we go to Setup, Mandatory Hardware, Acceleration Calibration, and you're going to click these boxes one after the other basically, but if you click Acceleration Calibrate, I will show you what happens in a moment, but very briefly let's just go back and show you the board. You won't be able to see it very well, and it's difficult for me to point it out, but there is an arrow just under the pen that is telling you which is the front. So you need to have this lined up so that you know that where the front is and the arrow. So with the arrow facing straight away from me, click on the first box, and the instruction is put the flight controller level on the desk and click the button again. Now turn it so that it's on its left edge, then onto its right edge, nose down, nose up, and then on its back, and then you'll get the message calibration successful. Going to the next button, just put the flight controller level on the desk and click. That's completed, and then the last button, that also is completed. That is basically now set up and the flight controller is ready to go. A couple of things worth pointing out. If you go to data, this box here, if you right click it, you can set the view count and you can set that to 1. If you then double click it, you'll get a list of items that will run way off to the right of the page, so you'll need to scroll across, and whatever you had selected or shown in that black box, deselect and scroll right across the page to S for sat count, and if you put a tick in that box, then that will then display the number of satellites that the GPS compass is seeing once you've got a GPS compass attached to the board. You now need to have the GPS compass attached, so any soldering you need to do now. Having assumed that you've done that, you go back to our setup, go to compass. Now you need to be outside when you do this, because you need to have set the flight control and powered up for 5 or 10 minutes to let it find a whole load of satellites, and then you're going to go and calibrate the actual compass. You click here to start, And then what you need to do is you need to have the compass and flight controller attached to a piece of board, something like this. Then when you start to turn it end over end to the left and to the right, you will see a green bar go across the screen here. It might go across more than once. Sooner or later it will tell you that the compass has calibrated. Once it has calibrated, you then need to go back into config and the full parameters list and check whether particularly this one here, compass orient, has changed. If it has, change it back to the 4 or the 0 it was before, depending on whether the arrow on your GPS unit is facing the nose, which is 0, or the rear of the plane, which is a 4. And then that basically is the setup all done. So I'm going to go off and solder this board up, and I'll come back in a minute and I'll show you what I mean about the satellites. Okay, so I've gone off and I've connected it all up like this. I've also soldered on a power lead which will power off the balance port of the motor battery. And I'm now going to connect it to the USB, and we'll go over to Ardupilot and have a look. It's actually been powered up for a few minutes now, so let's connect. And you can see in the box we've acquired about 20 satellites, 21 satellites. It's still acquiring them. The GPS unit is sort of hanging out the window, and you should be able to see that this is in fact where you are on the map. If you get all that, the chances are it's working fine. You can go and just fly and see what you get. Alternatively, there is a way of checking this, which would be to, in my case, put it in the boot of the car as it's an estate, and the GPS unit can get a clear view of satellites through the sloping rear window, and go and take it for a drive around the block. To verify that, you can go back to Ardupilot and you can click here and scroll across these various items, and the last one is something called data flash logs. When you click that, you can click review a log file, and I have one on my desktop that I made earlier. So if I go to that, that will open, and that will open in a window which I will just switch over to in a second. Just like this. You can make it a little bit more viewable by pushing that across here, and that is the track that it recorded for me just driving around the block. You can also, if I get rid of this and get rid of Ardupilot, load it into the flight plotter by going to load bin, click on the bin file. You need to have the schedule, whatever is in here, is set that up to ground test and test, and whatever site is in here you need to set to manual, then copy to origin, then submit. Zoom out with the scroll wheel, and if you press play, you should get a nice picture of your plane flying in the right direction, basically going around the block as I drove around it, like this. If for some reason the plane is going backwards, then what you need to do is go back into Mission Planner, connect to the flight controller, and in config, in the full parameters list, you've got AHRS orientation. That is the way that the board is facing in the plane. If it's facing with the arrow facing the nose, that should be a 0. You also have compass orient or compass underscore orient. That should be a 0 if the arrow is pointing to the nose of the plane, or if it's pointing to the rear of the plane, that should be a 4. So change that parameter, then click on write parameters. You should get a box saying parameters saved OK, but I would suggest disconnect and reconnect and check that compass orient is in fact 4. It's either going to be 4 if the arrow on the GPS is facing at the back of the plane, or it's going to be 0. It won't be anything else. That's pretty much it. Any questions, you can post them in the comments below, but thanks for watching.